Yeah, she gotta write the essay.
They leave a certain amount of spots. Probably like a 3 spots.
All right. First, I want to talk about the homework. Okay, for this time homework. I upload the homework file already, and I also upload the grading procedure for the final project. Anyone is not enrolled in senior design? Any one of you don't do the senior design? None, right? Okay. So this is a grading procedure on the senior design. You will read it, all right? But for now, and you also have the homework 5. Homework 5 is about do part of the design during the spring break, okay? And you may talk about ethics. I forget to put the ethics part on. I will do the correction on the homework and to add about ethics part, okay, that you will discuss on the facility design. For now, let's take a look on how to get 10 or how to get 100. This report get 10, okay, out of 100. Another one is 100 out of 100. The obvious difference is this. You see, thickness. Okay, that's the number one. This report is pretty thick, but this is not many pages. Alright? So let's take a look at the one that is 10 first. Okay. I have introduction. I know that it's too small to see anything. Pad facility design parameter. Have some table and put cost. Separate the cost into cost or something. And main equipment design and sizing. Tell me, copy it from Excel. Tell what it was, which one is what, use what, and look at this figure 1. Figure 1, they select 36 by 10 inch, and 36 by 10 inch, and it's not quite clear on how they do any of this, or just 36, 10 inch or something. So no drawing on this graph, you see. Just copy some page from Silver's. Sign-up sheet is here. Can you do the sign-up sheet? And formula. Didn't type. Okay. And do some of the line thing. No description or any explanation. Just say, okay, D equal to this, blah, 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 C equal to this. Just Excel. Copy and paste. And have some diagram. Other consideration. Okay. Type something more. Test facility. And show Hassen-Williams equation a little bit and have summary. Have some drawing. Okay. A little bit more drawing. 2,950 words. And include the page of the topic requirement. Okay. If you do this, you get 10. Okay? What's wrong with this report? If you do it like that, you get 10. Okay? What's wrong with that? Erosional velocity, you cannot just say that you will not have erosion problem. You have to prove with mathematics. You need to show the actual velocity inside the pipe. For the part that you have the highest velocity, just saying that you have no erosion problem without any calculation to justify your argument is not acceptable. What if you have CO2? With CO2, the pipe erosion problem become more. Okay. Pump sizing. The way you size the pump is not accurate. You need to do the same way that was in second exam. We didn't talk about the pump yet. Heater treater, you did not show the equation or how you substitute the value into the equation. You just show the graph. Compressor calculation, there's no calculation on compressor. You did not tell how many stages of compressor that we need. You did not tell what horsepower of the compressor that you need. You did not tell the discharge pressure and the suction pressure of each stages. Orifice plate, you show the equation, but you did not show how you substitute the value on how to get each and every parameter required in that equation. The way you assume the value of C means you totally miss the whole point of trying to justify your answer mathematically with calculation example and showing how you substitute the value. 6. Pipe size justification. You cannot use Hassen-Williams equation to do the calculation and get it accurately. Moreover, you miss the whole point of using Hassen-Williams equation. You did not tell how you assume the acceleration or pressure loss along the pipe. You miss the point that you have to assume the number of elbow, T connection, any expansion, any contraction that will happen in the flow line. You may not understand this yet. Heater treater, you show just one graph on how to get heater treater size. However, you did not show how you get your firebox rating. Without knowing the firebox rating, it is not possible to select the right model of heater treater. Weymouth equation, you have the Weymouth equation in your report. However, you did not tell which variable is for what. More importantly, you did not discuss this equation in the main text. You did not tell on what is this calculation for, where in your facility you did not tell why you select Weymouth equation over other equation. See? There is no discussion about Weymouth equation in the main text. Amine unit, glycol unit, hydrate formation discussion. You insert graph. The instruction page is very clear that you need to show hydrate phase envelope to justify your answer. You did not show that. Pipe size, discussion on the lag unit. Okay. There's no discussion on oil sample into the sampling part. The operator got paid based on the BSW content in the sampling part. We did not even talk about BSW in lag unit. There is a sensor to detect if you have water flow to the meter too much or not. You did not discuss about this sensor. Lag unit using either A.O. Smith meter or correlated flow meter. You did not talk about any of this in the lag unit section. What kind of meter that you are going to use, basically this lag unit discussion is incomplete. If you, okay, that is a version that get 10. Let's take a look on how you get 100, okay? I intentionally make it a little small so that you cannot really read it and copy his, right? You do the same thing, right? Here you go for it. So when I open it, I have table of content. The previous one doesn't have, okay? Table of content. And add the picture, introduction, background, introduction and background. Have some graph, show the parameter, oil flow rate, gas flow rate or something. Summary, facility diagram, show how does it look like, and show the pressure, okay? Talk about VRU, type of discussion of topic, lag unit. You see, many more paragraph, not 3-4 line about lag unit. Separator, discuss about it. Heater treater, okay, have some equation over there. Show some graph, show how they draw the line, okay? And tell what is the firebox rating. Show the available table, line heater, to Thomson effect or something. Maybe they don't have it, and have I think this one is about temperature for hydrate, okay? And have some calculation with the chart, and have this thing to justify that they don't need it or something. So this is to show that they don't need it, okay? So when you don't need something, it doesn't mean I skip. No, you need to justify why you don't need it, and you have to have some math behind it. Test separator, talk about the test separator, and gun barrel tank, copy the picture and discuss a little bit more. Tank gauging, how do they gauge the tank, how to not die during gauging the tank, okay? I talk about it during the class, right? So it is important enough to put in your report. Even though there's no H2S, people die because open the tank, okay? Hydrocarbon vapor get into their lung and they die. Oil tank, what is the size of the oil tank? Water tank made of fiberglass, blah blah blah. Immersion problem, and draw the line. This graph, it was not in the exam, but because it's so easy, you can use the silver textbook and do it, right? Okay, immersion, this is for heater treater. Will everyone need heater treater? Yes? Do you need it? Or you don't need it? Whether you need it or not, you need to show something. If you don't need it, say why you don't need it. Okay? Hydrate problem, okay, show some calculation, say, hey, I don't have hydrate problem. Pump, what kind of pump? And here's some equation. And friction factor, type some equation. This one, they type it. The previous one, copy and paste. No copy and paste, okay? You type it, okay? How they substitute the value, put it in, okay? This is what I'm talking about. Horsepower, how many horsepower? Compressor, talk about the compressor. D-high unit, copy the diagram, show it. Amine unit, okay? Coriolis flow meter, orifice plate, equation for the calculation, and unknown constant. How do they determine the unknown constant? They substitute the value and do something and get. So in orifice plate, the constant used to do the calculation is multiplication of several things. They show how to get each of them and multiply together. See, multiply them together. So unknown constant equal to this. Another one didn't do this. Okay. Pipe selection, how they select the pipe, pressure drop calculation, substitute the value, how they substitute the value, which equation. So this calculation example, pipe material, erosional velocity, how do they get the erosional velocity? They substitute the value in, that's what they get. And in this thing, they may need compressibility factor, Z factor, they show how they get it from the chart. Okay. And pipe side actual velocity calculation, that is V equals 60 something, that's actual velocity calculation, right? And so this is actual velocity calculation. Heat transfer calculation, we will study about this too. I will have the template for calculate the heat transfer. How much is the temperature drop? Change of facility over time, how will the facility change over time? Water injection consideration, talk about it, multi-phase flow consideration, flow assurance. And when you have the chart, show how to draw a line on the chart. Okay, this is appendix. Some calculation already in the report body. Okay, this is appendix. Appendix show how do they do the tank gauging and heater treater, diameter calculation, and all other calculation in the back. Okay, compressor calculation, how do they get the temperature of each state, and they type it, they didn't copy and paste. Okay, brake horsepower calculation, how they substitute the value, put the equation there, substitute the value in, and everything type, right? No copy and paste. Pipe selection, have a table for the pipe, pressure drop calculation, show the equation, show how to substitute the value, show how much they get. Okay, thermal conductivity, this is about the heat transfer consideration, and this is how they do the heat transfer thing, get epsilon over D, Reynolds number, thermal conductivity, Nusselt number, blah, 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 blah. So calculation attached in the back, how they do all of that, how they substitute the value. And additional calculation in Excel, show the screenshot. And this group also submit the Excel spreadsheet on how they do all that calculation, and the one that is in here is just an example. And do all this, total work 9,000 something, 55. And they get 100. Okay? What do you want to get? Somewhere in between?
3,000.
You cannot get 3,000. Okay? So,
I just want to pass the class.
what?
I just want to pass the class. You know that you're teaching a second semester senior class?
not many people fail this class. And last semester, just one student got C. And the rest either B or A, like 50-50 chance. That's last semester. But the year before that, it's not like that. The difference is, the year before that, on average, miss the class 5 times. And some people miss the class 14 times, 10 times. They just miss the class, okay? And last year is the first year that we forced everyone to come to class. If you don't come to class, then you don't get any grade or anything. Yes? You have a question? No
Yes,
question?
yes, sir. I was just going to say, I don't mean to be disrespectful. If I'm being honest, you're very intimidating with how it is you say you're going to grade things.
Is it too difficult?
It's pretty scary.
You see, it's not only one group that get 100. This group get 100. Okay. That group get 100, but it's not only one group get 100. There are some group that did less than that and get like 95, 99 or something. But you don't need to get 100 to get A. Okay. But if you do that much, you get that much. Okay. And question about the report. Any question on the report? Yes.
70 look like?
70? Actually 70 look similar to the 101, but didn't show the erosional calculation and didn't show the heat transfer calculation, didn't show the pressure drop calculation, do some mistake in compressor calculation thing. But the lengthwise or something, it looked just like that. And to be fair, for those students who graduate already, so we use the same standard of last year. Okay? I already showed you how 10 look like and 100 look like. And decide for yourself how much do you need to pass. Okay?
Can you post those?
Question? Yes?
Are you going to post those?
No, I'm not going to post those. I'm not going to post those.
Are you going to give those copies away like you give like
It's because it's the same, right? If last year project is different than this year project, and I did not show you all. In addition to this thing, they also submit the Excel file to show that they didn't just copy from somewhere else, but they did it. Even if you get this, you don't have Excel file, okay? You need Excel file to submit it together with this. Exam cover anything like last week, okay? And before today. And we have one compressor calculation question. Who have not tried to do the last year exam by yourself? Who try? Okay, cover you. How long does it take to do it? Last year exam? 3 hours? How long did it take for you to do the last year exam? Yeah. 4 hours? Last year exam was to be done in 2 hours. Okay, it was to be done in 2 hours. If you did it 4 hours, try to request 2x time, okay? So it was to be done in 2 hours. If you haven't practiced, when you do the last year exam, I know for sure that you read the solution and it's just fine, okay? You go through the calculation, it's just fine. The point is, I suggest to practice to improve your speed, okay? Improve your speed. Oh, one announcement about this coming exam. For the first part, on the ethics part, I use the word you do blah 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 blah. Is that ethical or not ethical? Please consider that as a hypothetical situation. It's not real. I say you did blah 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 blah. Is that consistent with engineering code of ethics? True or false or something? It's just hypothetical, okay, situation. Is not real. And if that is, you may replace that word with student A or something. Okay. Are you ready for exam? No? There are calculation of 90 points. And true or false, like 30 point, okay? You don't need to get 120, you just get 100 is fine. Okay, let's continue from last time. We have, who haven't finished the homework today yet? Rohan Nagrawa, which one have you haven't done?
Last question.
Last question.
Yeah, it's the one.
If you didn't do the last question and the rest you did it fine, you get 9.6, right? Because it's 2 point for each question. If you do everything except the last question, you get 9.6, which is, you don't need to get 10, it's 9.6, it's okay. It's good enough, isn't it? Okay, how do you do the last one? I did not post this to the blackboard, okay? And you may type or explain something. You may need to do it in Excel, okay? So the question is about if I have a certain size of separator, what is the droplet size that will be removed, okay? And the separator equation, you remember equation with 420 something? It is in, I think, lecture 3 separator. Very last slide. Who finished the last question without any help from me? Oh, Steven. Just Steven and you. What's your name? John. Just two. Who else? That very easy enough. The rest get help from me, right? Either you come see me or Arya. Last question is about this equation. Okay. Horizontal separator half full. Diameter is known. L effective can be calculated, and the rest is just this equation, right? And I ask you, what is dm? What is the droplet size that will be removed? Okay. This question is intentionally putting in on homework because it cannot be put on the exam. It's too much on the exam. It can be in the exam for the numerical method class, okay, but not this class. So we start with this equation that you need to use just 3 equations. This equation, okay, for horizontal separator, and the equation is about Reynolds number, or terminal velocity. So the second equation is about terminal velocity equation, this one, right? And the last one is Reynolds number and Reynolds number equation. Okay, Reynolds number equation, this one, and friction factor or drag coefficient equation. So we need drag coefficient, Reynolds number, and horizontal separator sizing equation. Yes. Oh, you didn't know it yet? You didn't know this one yet? You did not know that, Tris? You don't? Everyone else know it, right? Yeah. I think it's a concern if you don't know it. I don't tell if it is on the exam or not. I don't tell you that, but everyone else knows it. Yes. So we need this one. What I do is I start with that 420 equation. Okay. The diameter is known, effective length is known, everything else is known. I assume CD equal to 0.34. So dm is not known. The only unknown in this equation that I can calculate it by assume the value of C sub D, right? Once I know dm, I can calculate velocity. Okay, Vt equal to something. I can calculate that. Okay, because I know dm and cd, but cd is a assumption, right? I assume something for cd, 0.34. Okay, then I calculate terminal velocity. I put in Reynolds number equation. I can calculate Reynolds number. Once I calculate Reynolds number, I put that Reynolds number in drag coefficient equation. Then I can calculate the new drag coefficient, the new CD. The output CD and input CD they're not going to be the same unless my guess of C sub D is the correct one, right? So in my Excel sheet, it looks like this. So I start from diameter, effective length, temperature, compressibility factor, everything, put it in. Open that website. CD, let's assume 0.34. Okay. Left hand side of that 420 equation, do the calculation, get dm, then calculate velocity, calculate Reynolds number, calculate the new drag coefficient, and look at the difference. The difference is input minus output or output minus input, right? And what's next step? Trace, what's next step? Do you know? What? I use go seek. Who have not used go seek before? Tell me. Everyone used go seek before? Is that so? So if I select anyone to come to the podium, you can do it. So I click that data, what if analysis, go seek, set the value in that cell to be 0 by rearranging the input cell. Click it. It do some trick. And then I have input CD equal to output CD. Very close. Okay, the difference almost 0. So this means my diameter, droplet size diameter is correct. 110 or something. So if I use 36 inch by 10 feet, it can remove 110. You may not do it like this. If you want to do, okay, 0.34, right? If you want to do iteration, you can do iteration in Excel if you don't like GoSeek. So to do iteration, I have to link the cell, this thing equal to the output from the previous one, okay? And you will have to, okay, number of iteration, 1. Go to that, plus 1. How many times do you think you have to iterate if you don't like GoSeek? It's many times. Let me show you some graph. So I show this value, C sub D value, output, versus number of iteration. So we input 0.34, it go up, go down, fluctuate a little bit, and after 10 or 12 iteration, we approach 0.225. And 25 iteration, we get 0.23 or something. So if you do this, you have to do at least 12 iteration. Okay, 12 iteration. And if you do 36, you can match couple more digits. Otherwise, use GoSeek. Have you learned about Newton-Raphson method? Yes, you can use that too. Gauss-Seidel method, bisection method, all those numerical methods work here too. Or just use GoSeek on solver. And if you write something on how to do this, okay, you say your method is to start from somewhere, do this, but you cannot use GoSeek. Maybe you get 0.4, and 0.4 or 0.5 with 9.6 add together become 10. Okay, good. So try to do it. Question? No more question. Question about exam? Okay. Don't come to see me in my office then, especially tomorrow. Okay. Tomorrow after 12:30, don't come to meet me. Okay. In any case, if you want to knock the door, knock Mr. Bulat's door, not my door. Okay. Or you can go to see Arya. Tomorrow in the afternoon, don't come to see me. Okay. Today you may, but you don't have any questions now, right? Or you have questions?
If you cover all the way up to lecture 7 to the
is covered all the way up to last Thursday. And last Thursday is anything before this slide, right? Last time we stopped at this slide. Anything before this slide. Before this slide, we have the chart, we have horsepower calculation, we have discharge temperature, discharge pressure, and you know how to do Renault number, you know how to convert from mole percent to mass percent. Yes, question.
Do you have any examples of that horsepower per stage equation being used?
Do I have? I think so. I think it's 2016 open book. Is it? 2016 open book. So on 2016, okay, this O exam, I have something about coil size, minimum coil in the diameter, have some table. Okay, that's 2016 equation, separator equation, and vertical separator. Okay, that's separator. Pump problem. Oh, that's my compressor equation. Maybe second one. Exam 2 open book. Gas pipeline design. I think one of the OXM has it. Maybe 2017. Did you find it, Ryan? You didn't see any of that.
There's a compressor problem in 2017 that uses the basic and delta H equals G minus W equation, not the W equals whatever.
It's basic for you, right? Yeah. Okay. Yeah. Some people take 4 hours to do it, okay? 4 hours, 6 hours. Okay, last year exam. Last year exam. Calculation part. All the picture, you know what it is, right? You know what it is. Those picture thing. The compressor part. That's my compressor equation. Oh, look at this. What is the local horsepower? Compression ratio. Last year, some people use compression ratio of different stage to be different value, which is wrong. Okay? You have to use every stage have to have the same compression ratio to minimize the horsepower. So it's just this. Yes, it's too basic, right? Is it? Can you say about if it is more than one stage, like 3 stage separator? Can you tell about discharge temperature, discharge pressure, or something? By the calculation method. The equation is, or the equation is not here, but is in the first page of this exam. So this is just one of them. And maybe this time is a little different. But yeah, it's very easy, just put it, this time they use the chart. But in the example I include the equation. Do you know how to use all those equations, Ryan? The equation given in the instruction page. You do?
That's why I was asking.
Ah, equation, you have never seen it used? Just the derivation. Do you know what unit of those parameters? Exam 1 instruction. I mean, this one. What is TB? Base temperature. What is the unit? Rankine, correct. TS, suction temperature. Rankine, PD. Discharge pressure, suction pressure, PSIA. Okay. The compressibility factor is not much, it's just this, right? Put everything in and get horsepower per mmSCFD. Very easy. And what about this? Röntgen, PSIA. Put it in if you know the compression ratio. This is compression ratio, right? And then you can get discharge temperature. Good? Yes, Rohan.
Could you go over the first workout problem 2017 exam 2? That's a gas compressor question.
You mean this one?
2017 exam 2.
Oh, 2017 exam 2. 2017 exam 2. Do you think I may repeat that?
It's a gas compressor question.
Exam 2. Okay. 2017 exam 2. Let's take a look at it. Okay, brake horsepower. Oh, this is more like it, right? This is more like it. Have more question. Exam 2. And that's just instruction page. You have piston. Can everyone do all this? Just easy math. You can, right? Did you take a look? Is used in the derivation of theoretical horsepower. If you don't know it, you should know it before the exam date, I think. So that's a true or false question. Oh, look at this. Is it fair to put this into our exam, Rohan? Yes, it is. Yes, it is. It is very fair to put this question into my exam because what? It is about discharge pressure, discharge temperature. This is just one equation, right? Number of stage. Number of compression ratio between each stage should be between 3 to 4. Just use 4, okay? I think in the exam maybe you cannot go more than some value, okay? And it will tell, the exam will tell, and you should be able to tell, okay, how many stages, what is discharge temperature, discharge pressure. To do all this, we use the grader use Excel, but okay, you just put the value into that equation and you specify the 3 stage and oh, look at that equation. It was given, right? I gave that equation too. Oh, did I have that equation? Yes, it is there. Compression ratio per stage equal to that. PD over PS super over 1 over N. So R of each stage, and PD and PS is what? Initial suction and final discharge, right? Yes.
How did I was trying to solve it and I don't know how to come up with the number of stages I need to.
Oh. Everyone else know that, right? No. You know it, yes, very good. Number of stages is this. You never know. To do it, let's say I want to, in the exam of that year, I want to compress to, what is the discharge temperature? Compression equation, 10 mmSCF from 65 to 215. Step 1, convert everything into PSIA. Step 2, assume one stage. If we use one stage, what is the compression ratio? So compression ratio is 215 divided by 65, right? And is if n equal to 1, then it is okay. So then you stop. If the discharge pressure is 10 times more than this, if you use just single stage, the compression ratio will be a lot. Then you do 2 stage. If you do 2 stage, what is the compression ratio per stage? If it is between 3 and 4, you stop and you use that number. If it is more than 4, you add more stage. Just that. Good? Try single stage first. If the compression ratio is more than 4, try 2 stage, 3 stage, 4 stage, etc. Question. Very good question from him because this is very likely to happen in the exam. Are you ready for this? Did you prepare this particular example? If no, try it. Try it now. You can still come to see Arya tomorrow, right? Or come to see me today. Not tomorrow afternoon. Question, yes.
Yeah, pressures from stage to change, stage to stage, those change with the pressure ratio obviously stays the same.
Compression ratio stay the same in every stage.
Pressures change, right?
The pressure has to change. For example, you can go from 100 to 300, and then 300 to 900,
So
and then compression ratio is 3. Yes.
your first one, I guess, set the end to another.
How do I get the How do I get the number of stage? Is that what it is? The number of stage, I assume it to be 1, and find out what is the compression ratio. If it is more than 4, I assume the number of stage should be 2, and do the calculation again. And then assume it to be 3, and do the calculation again. Whichever the smallest number of stage that make the compression ratio to be that between 3 and 4, I select that. Compression ratio must be the same between each stage, okay? And you can calculate the temperature, discharge temperature of each stage. Can you? Maybe I will know it on Thursday. Maybe I will know. You may not answer me anything now. It's okay. I will know it later. Let's continue with what we have last time. For the compressor, there are several valves that we have. Okay. And one of them is flare valve. Flare valve. If flare valve is open, gas coming in, it go to vent. Okay, it go out. So that's flare valve. Recycle valve. Recycle valve is It's that one, right? When we finish everything, it go back to the recycle. So instead of turn it on and turn it off, turn it on and turn it off, we open the recycle valve so that even though new gas doesn't come, then I don't have to turn it on and off. Think about vapor recovery unit. It's not all the time that I have vapor, right? Sometimes I don't have any vapor. Do I turn it off? And when vapor comes, I turn it on? I should not do that. If I do that, I have to turn it on and off many times. Instead of that, I open the recycle valve. Okay? There's a suction pressure throttle valve to reduce the pressure. Okay, it's like a choke. Put it in front of this thing to not exceed the suction pressure. Require suction pressure. Okay, and pulsation bottle we'll talk about that later. Calculation. Piston displacement calculation is not on the exam. Okay, because it's not last week. You may consider to put it on your report. It's very easy, just copy what they did, right? Piston displacement is the actual volume swept by the piston per minute. Okay, single acting. Look at this. Piston displacement is dc squared multiplied by s multiplied by rpm divided by 2200.